So today we're going to be looking at sample spaces. And so first we're going to define what a sample space is, and then we're actually going to look at some. We are going to find some probabilities today, and we're going to get into our first probability rule. There are lots of probability rules. We focused on 7 main rules, and today we're going to learn our first one. So a sample space, we use the letter S to mean that we're looking at a sample space, and it's just a list of all the possible outcomes. Now, you don't have to, as long as I know what you mean, you don't have to write out words. So you'll see in a minute when I do the sample space for flipping a coin, you can, if you want to, write out the words heads and tails, or you can abbreviate with H and T. If your abbreviations are obvious, then that's fine. If, let's say, for some odd reason you decide to use 1 and 2 when you're writing the sample space for flipping a coin, you need to tell me that 1 means heads and 2 means tails, okay? But if it's an obvious abbreviation, you don't need to explain it to me. So we're going to go through and we're just going to list some sample spaces so that we get practice with that. And then we're going to use our sample spaces to find some probability and then get into our first probability rule. So we're going to list the sample space for flipping a coin. So this is what I was talking about. We use S, sample space, put an equal sign, and then we use these fancy brackets. I'm sure they have a name. I don't know what they are. They're the squiggly brackets. And like I was saying, if you want to use H for heads and T for tails, that's obvious what those mean because we're looking at flipping a coin. You don't have to explain them to me. So if I flip one coin, there's only 2 outcomes, heads or tails. If I want to find the sample space for rolling 2 dice, and then record the sum. So the sum is my sample space. So I'm going to put S equals, and then I have to think about all the different sums I can get when I roll 2 dice. So the smallest, that's where my head starts first, would be I get an ace or a 1 on the first dice, and then a 1 on the second dice. When I add them, I'm going to get 2. If I roll a 1 and a 2, my sum is 3. If I roll a 1 and a 3, I get a sum of 4. If I roll a 2 and a 2, I also get a sum of 4. So there are multiple ways to get a sum of 4, but I don't have to write 4 multiple times. 4 is an outcome. There's a bunch of different ways to get that outcome, but it's only asking me to record the possible sums. I could have 1 and 4, which make 5. That would also be 2 and 3, 3 and 2, 4 and 1. 6, 1 and 5, 2 and 4, 3, 3. I could have 7, 1 and 6, 2, 5, 3, 4. I could have an 8, 2 and 6, or 3 and 5, or 4 and 4. I could have 9, 3 and 6, 4 and 5. I could have 10, 4 and 6, or 5 and 5. I could have 11, that's a 5 and a 6, or I could have 12, 6 and 6. I can't get anything higher than 12, so that's the end of my sample space. And then, of course, to keep things interesting in probability and not always straightforward, we like to throw questions in there like, what's the sample space if I roll a die and then flip a coin? So when I roll a die, I could get a 1, a 2, a 3, a 4, a 5, or a 6. And then when I flip a coin, I can get heads or tails. I'm not going to write it on the line because it'll, in my opinion, gets too messy with the one above. So I'm going to write it below. So if I roll a die, like I said, I could get a 1. And then I flip a coin, I could get heads. So 1 with a heads. Or I could roll a 1 and get a tails. I could roll a 2 and get a heads, excuse me, or 2 and tails. And I'm gonna go through, I don't know why. I've been doing heads first, and on 3s I switched them, sorry. But so I could get the numbers 1 through 6 with heads or tails. And I'm going to sneeze. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different outcomes. Sometimes you're going to have to write a big list, which is what we're going to do here. So if we were actually in person, this is the one where you guys would get to try it on your own. I'd walk around, check. But I can't walk around and check your papers, so you guys get to listen to me do it. So we're going to write out the sample space for rolling 2 dice. So the number I get on the first dice and the number I get on the second dice. It's a bigger list, so I'm going to just put S over to the side and then make a big bracket. So I could roll a 1 on my first dice and a 1 on my second dice. I could roll a 1 on the first and a 2 on the second, a 1 on the first, a 3 on the second, a 1 on the first and a 4th on the second, 1 on the first, 5th on the second, or a 1 and a 6. That would be all the possible ways that I could roll a 1 on the first dice, and then all the different possibilities of the other options on the second dice. I could get a 2 on the first, and a 1 on my second, 2 with a 2, a 2 with a 3, a 2 with a 4, 2 with a 5, 2 with a 6, and that would be all the possible ways if my first dice was a 2. And then I could have a 3 with a 1, a 3 with a 2, 3 with a 3, 3 with a 4, a 3 with a 5, or a 3 with a 6. And then 4 and 1, 4 and 2, 4 and 3, 4 and 4, 4 and 5, 4 and 6, and then we have 5 and 1, 5 and 2, 5 and 3, 5 and 4, 5 and 5, 5 and 6, 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, 6 and 6. And that would be all the different possibilities. I can't make these squiggly brackets as well for the right hand side. That one was actually pretty good. Proud of myself. So, like I said, across, I have 1 for the first die, so that's all the different ways that I could get 1 on the first die. going down would be the opposite. So notice the first die changes, but the second die stays the same. So I am able to see that I have all the different possible outcomes. And there are 6 across the top, 6 going down, which means that I have 36 total outcomes that are possible when I roll 2 dice. Are there any questions before we move on into doing some actual probability questions? All right, so another definition. When it comes to probability questions, they use the word event. So they'll say, what's the probability of event A, event B? Usually they only use A and B. So an event is an outcome or set of outcomes. And an event must be a subset of the entire sample space. So in our first example, a coin is tossed 3 times. We're going to list the outcomes in event A of getting exactly 1 tail, and then we are going to find the probability of event A. Now, when you're asked to find probabilities, sometimes they, I say they in general, people who write math questions, including me, sometimes we type out the actual phrase, what's the probability? Sometimes we just use notation. So if you see a capital P followed by parentheses with something inside, they're asking you to find the probability of what's inside the parentheses. So in this case, we want to find the probability of A. And they tell us event A is getting exactly 1 tail. So we're going to create our sample space for a coin being tossed 3 times. We're going to list the outcomes for event A, and then we're going to find the probability of event A. So if I toss a coin 3 times, I could get 3 heads. I like to start with one where everything's the same. That's how my brain works. You don't have to list them in the same order as me. So I have 3 heads. That's the only way I can get 3 heads. I can get 2 heads and 1 tail. And I could get that by heads on the first 2 tosses and tails on the 3rd toss. Or I could get heads on the first, tails on the second, and heads on the 3rd. Or I could get my tail first, followed by 2 heads. Then, so I went with 3 heads, 2 heads, so then the next would be 1 head and 2 tails. So I could get my head first, followed by the 2 tails. Or I could get tails, heads, tails. Or my heads could be the very last toss. And then I also have to think about the possibility that I get 0 heads, which would mean 3 tails in a row. So notice that when I was thinking through the sample space, I started with all 3 of them matching and then said, okay, now only 2 of them match. only one of what I started with, and then none of what I started with. That's how I think through it to make sure I get all the possible outcomes. You might have a different way though. So there's 1, 2, 3, 4, 5, 6, 7, 8 different outcomes in this sample space. And we are interested in event A, and that is getting exactly one tail. So the first thing it asks us to do is to list the outcomes in event A. So we're gonna write down the possible ways event A happens. That's one tail. So that would be this one, and this one. 2 heads followed by a tail. Heads, tails, heads, or my tail followed by 2 heads. So there's 3 ways that event A would happen. So when we find the probability of event A, we know there's 3 ways that A happens, and there are 8 total outcomes. So there's 3 ways to get one tail out of 8 different outcomes. Now, we tend to, I think I said this yesterday, but I can't remember, probabilities tend to be written as decimals. So very rarely will you see it written as fraction. It does happen, but it's rare. So I'm going to ask that you guys turn your probabilities, even if you have it as fraction, turn it into a decimal for me, please. So 3 divided by 8 is 0.375. And so if we were to put into words what that means, 0.375 is about 30, not about, it is 37.5%. So 37.5% of the times that I throw a coin 3 times in a row, I'm going to get exactly one tail. Now that would be over a long series of repetitions of throwing a coin 3 times. I would not expect to throw a coin 3 times for 8 repetitions and get one tail 3 out of the 8 times I did it. It is possible, but it's not likely. Probability, remember, is what happens over a long series of repetitions. The next example, it says a die is tossed 2 times and the sum is recorded. List the outcomes in the event A of getting a sum of 7. So event A is getting a sum of 7. By the way, sometimes they'll define A and then they'll ask you to find the probability of A. Sometimes they'll define A and then they'll still say find the probability that the sum equals 7. So just know that sometimes it'll show up like that, even if they define what A is. They use them interchangeably. So a die is tossed 2 times. We have that sample space up here. Up here, we wrote it thinking through, okay, if I roll a die and then I roll another die, that is this sample space. But if I roll it 1 die and I pick it up and roll it again, I'm still going to end up with the same sample space. So I'm not going to rewrite it down here. I'm just going to refer to it up here. But we do need to list the outcomes for event A. And event A is that we get a sum of 7. So if we look up at all these possible outcomes for rolling a die twice, which of the outcomes would give us a sum of 7? Either throw it in the chat or unmute yourself for me. Which 6, Chloe?
The ones in the diagonal line, like starting at 1, 6, going down diagonally to 6, 1.
So Chloe says 1, 6, which 1 plus 6 is 7. And then she said going down diagonally. So 2 and 5, 2 plus 5 is 7. 3 and 4, 3 plus 4 is 7. 4 and 3, 4 plus 3 is 7. 5 and 2, 5 plus 2 is 7. And then 6 and 1. Thank you, Chloe. So we're going to list them, even though I highlighted them. So like Chloe said, 1 and 6, 2 and then a 5, 3 and then a 4, 4 and then a 3, 5 and then a 2, or 6 and then a 1. So there are 6 different ways we can get a sum of 7. So if we were asked to find the probability that the sum equals 7, we know that there are 6 ways that we can get a sum of 7, and there are 36 possible outcomes. And I know this is 1/6, 0.16, yeah, 0.166666666 forever and ever and ever. So again, if we were to think about what that means in words, if we were to roll a dice 2 times and record the sum or add the 2 numbers together, the probability that they would add to 7 would happen about 16.666% of the time. Any questions before I flip to the next page? Alrighty. So we're going to get to our first rule, and somehow I could have sworn I typed a question down here and it's not there. So we're going to write it in, but we're going to get to our first rule of probability. Just a couple things to keep in mind. The probability of an event has to satisfy the statement that 0 is less than or equal to the probability of event A, which is less than or equal to 1, which is just a really fancy way to say that the probability lives between 0 and 1, which we talked about yesterday. All probabilities have to be between 0 and 1. If S is the sample space in a probability model, then the probability of S is 1. So if I was looking at rolling 2 dice, we know there's 36 ways for that to happen. And I asked you to find the probability that we, I don't know how to phrase this. What's the probability that we get, and let's say I listed all of these outcomes. So I listed the sample space. You would get 1. There's 36 ways to get these out of 36 different outcomes. So if you're asked to find the probability of your sample space, it's always 1. So our first rule is called the complement rule, and the complement of any event A is the event that A does not occur. We use A with the superscript of C. And so if you're asked to find the probability of A complement, or you may hear me say the complement of A, they're used interchangeably. It comes from 1 minus the probability of A. So the definition, a complement of any event, is the event that it does not occur. And probabilities, if it's a legitimate probability model, they should always add to 1. And I love that they use the word legitimate. I don't know why. Probability model, probability model, all probabilities add to 1. I don't know how many years I have thrown a question on the test where I give them a probability model, and if you add all the probabilities together, it's bigger than 1. And I ask kids what's wrong with the probability model, and every year I still get some kids who are like, nothing's wrong with it. Sorry, I started talking and I stopped writing. All probabilities add to 1. So the probability of event A and the probability that event A does not occur need to add to 1, which is why we can subtract from 1 to get our complement answer. Another way to think about that is that the probability that A happens plus the probability that A does not happen is equal to 1. And the question that I could have sworn I typed in there, but it's not showing up, is what is the probability that we toss a die twice and our sum does not equal 7? And the reason why I chose that is because we had just done the probability the sum does equal 7 when we toss the dice twice. So this is the complement of this one. So since we know the probability the sum equals 7, to find the probability that the sum is not 7, we can do 1 minus the probability the sum equals 7. So this would be the probability of A complement, and this would be 1 minus the probability of A. We know that the probability the sum equals 7 is 6 over 36, or 0.1666. Repeating, I'm going to use the fraction to begin with just because this was a non-terminating decimal and I don't want to have a rounding error. So when I do 1 minus 6 divided by 36, I get 0.833333. So the probability that I roll a die twice and the numbers don't add to 7 is 0.8333. Repeating forever. So on your homework, you will have some questions where you have to give the sample space, and that's it. You'll have some questions where you have to give the sample space and find a probability. You'll have some questions where you have to find the sample space and the complement of a given event. And I posted the assignment and then I went back and looked at it, and I decided I really don't like questions 9 and 10, so I want you to skip 9 and 10 on your homework, because honestly they're just, what's the word, tedious. They're just tedious, and so I don't really like them. Are there any questions? No?